this is where your point estimate comes in. You have your mean for your population. You have your sample mean. When you do your L1 table and you find your mean, there's your X bar, your sample mean. You have your variance squared for your population. You have your sample variance squared. There's your variance for your sample. You have your standard deviation for your population. You have your standard deviation for your sample. These are where our point estimates come from. We're going to use your sample estimates to estimate your population. And one more thing you're going to see soon, you have a proportion, and for your sample, we have what's called a p-hat. A little arrow over the top is a hat. So we call this guy p-hat. So these are your population parameters. These are your sample statistics ones that model your point estimates. So when you see X bar, you know this came from your sample, and we're using it as a point estimate for your population needs. So that's where your plus or minus is going to come from. So when we do this, we're going to do your mean plus or minus your margin of error. So we're going to have to use your sample point estimate plus or minus your margin of error. Today we're going to figure out where that margin of error comes from. Okay? So these are your population parameters and your sample statistics ones that we have to use. Okay. Now, before we can go any further, we have to talk about your level of confidence. Your level of confidence is the probability, and it's probably on the note sheet, is the probability that the interval contains that population parameter. I want to figure out where my population mean comes from. So I set up a point estimate using a sample mean. I set up a margin of error, and I say to and from this. I want to make sure that when I actually look at my population, that it falls between those numbers. That's how confident I want to be. If I want to be very confident, I'm going to make my margin a little bit larger. If I want to be confident, okay confident, I can narrow it down a little bit. So we use a z-score to help us find the level of confidence. Now, this z-score is associated with your level of confidence things. And feel free to add to this table, because especially for homework, you're going to see the same ones over and over again. Now, where these values come from is not from your table for 90%. It comes off of this. If I take my graph and I use 90% of your data, and we did this before, and 90% falls in here, it's got to be symmetric. This is where my 90% falls. How much is left in my two tails together? 10 together, and each one has 5. So you first have to figure out, there's 10 left here, so 10 divided by 2 gives you 5, so each tail has 5%. This has to be symmetric, and it has to add up to 100. From there, you can find your z-score. We've done this before. You can find your z-score. This is the negative z-score. This is the positive z-score. They're exactly the same number because your graph is symmetric. Now, we just qualify this with a little c. This is the z-score we want to use for your confidence interval. So we do second pairs, we do your inverse norm, and we look up 0.05. We've got to move this decimal 2 places. We look up a z-score that has an area of 0.05, and we find it to be 1.645. Now I said there was 2 that always go a little bit extra. That's the 90 and the 99. Okay? So if we had to find the 95%, we would do it the same way. So what if we have to find an 80%? A z-score for 80%. Let's see if we can find that and add this to your chart. Here's your curve. Here's 80%. How much is left to share on the tails?
10% on each side.
10% on each. There's 20% left. 10% on each side. So, this is 10, and this is 10. So we do inverse norm, 0.10. So do inverse norm and tell me what you get for this guy. Should I let you do it for me? So you can add 80% to your chart. 80% is one of the ones they occasionally use. Courtney's on it.
Negative 1.28.
Wait, say that again.
Negative 1.28.
28. Okay, now notice, all of these z-scores are listed as positive, right? Even though what you look up is the negative, we list all the z-scores as positives. We don't want to put any negatives when we do the ZC, because this is going to help us with our level of confidence. So yes, you're looking up the negative number. Just remember not to use the negative sign. This is negative 1.28. This is positive 1.28 on that chart over there. Sorry.
So you use only the positive?
You use only the positive. Notice only this is all positive numbers.
That's for all the time?
Whenever we're going to put this in your margin of error formula. Whenever you find a z-score associated with your level of confidence, we're going to call it the z sub c. We're going to always use the positive number. So as you do these and you find a different one, add it to your chart. Occasionally you might see a 98%. Most of the time they use 90, 95, and 99. Those are the three most popular. 99, usually, like especially in the medical field, in the law field, you want to be as accurate as possible. You use a higher level of confidence. Okay, so now we're going to take that and we're going to incorporate that into one of your formulas. We're going to find your margin of error formula. This is where we do this. This is this guy. You guys with me? I want everybody working on this.
What page is it
Um,
Is it in this packet?
page 282. Yes. Should I go back to the table? So now, this is your margin of error formula, right here. This is your standard deviation for your sample. This is this guy. So what we do is this. ZC, your population standard deviation over the square root of how many are in your sample. This is your sample. This is your population standard deviation. This is what we just found, your z-score for your confidence interval. You're going to put it all together, and we're going to make a margin of error. That's the plus or minus guy. When we say 3 plus or minus 2, 2 is your margin of error. Okay. Now, if your sample size is greater than or equal to 30, you can also use your sample standard deviation. And you really don't have to worry about that because that's the way this course is built. All right, so we're going to use this formula, and we're going to find the margin of error for some of these things over here. I'm just going to slide this down slightly so we can find your margin of error for this guy. From example 1, at a 95% confidence level, we want to build a margin of error for the mean number of sentences. Now remember, in example 1, they put everything into their L1, or they added them all up, divided by how many there are. And because our n is larger than 30, we can use your sample standard deviation. This came from example 1. So we want to build this formula. We need our ZC. We want a 95% confidence interval. So if you don't have your chart handy, you take this. This is 95 in the middle. How much is left out of 100? 5. So just subtract this from 100. take 5 and divide it in half. Each one of these is 2.5%. So how do I get 2.5 into a decimal? That's a percent.
0.025.
0.025, same rule, move it 2 places. So I'm going to do inverse norm on 0.025. That's going to get me my ZC. These are the only 3 pieces that I need to plug in there. So anybody come up with that? It's also on your chart, but I want you to get used to finding it in case you don't have the chart in front of you.
Negative 1.96.
1.96. So remember, we're going to use the positive. We're always going to put the positive in here.
Oh. I got a negative in my pocket.
Right, but we're always going to put the positive on our chart. If you use the negative, it's not really going to have that bad of an effect because we do plus or minus margin of error. So it's going to just resolve itself anyway. 100 minus 95. Because it's 95% of your data here. So we have 5% left over. Okay, so now all we have to do is plug this in. 1.96, your standard deviation, 5.0 over the square root of how many are in your sample? 54. Now, you can plug it in your calculator just like you read it. You don't need any extra parentheses. So if you plug it in your calculator just like you read it, you get 1.3. This is your margin of error. That's your margin of error, 1.3. 1.3 sentences, this was your sentences for your advertisements. So, go ahead.
You just put it in the calculator 196.
1.96 times
Oh,
5 divided by the square root of 54. Order of operations will do it exactly that way. And did you get 1.3?
yeah, I just forgot the
The decimal. Yeah. Now, if you notice, and you put this in with a negative, you're going to get a negative 1.3. It's okay, only because when we do this, we take your mean plus or minus your margin of error. When we do the plus or minus, it's kind of going to wash itself out. But your margin of error should be a positive number. It's the, God bless you, it's the leeway on both sides. So now, to build your confidence interval, we just take your mean, and we add and subtract 1.3. So here's where your margin of error goes. 12.4 minus 1.3 gives us 11.1. That's the low end. 12.4 plus 1.3 gives us 13.7. There's the upper end. There's your interval. This is called your confidence interval. And another way to write this is with an inequality. 11.1 is less than, this is less than this. Now, here's the thing. You want to be 95% confident that your population mean, when you figure out what the mean, these were sentences for advertisements. Once you figure out the mean sentences for your advertisements, for the population, you want to be 95% confident that that mean is going to fall between 11.1 sentences and 13.7 sentences for their advertisements. Okay? Does that make sense? You want to be 95% confident that the population mean is going to fall here. Remember, this is called inferential statistics. Right now, we figured out from our sample of 54 articles, we saw how many sentences each advertisement used. We don't know what the population does. So we're inferring this information to figure out what the population does. We're using our sample. But we want to be confident that if we could figure out a population mean, that it would fall between those two numbers. Does that make sense? I don't want you to miss the meaning of this just because we filled out a couple of formulas. The meaning of this is we don't know the population, so we figure out our sample and we infer something about the population. This is your inferential statistics at work. Okay, so now, another way to do this, on your calculator, have a great little test on your calculator for those of you that have it in your hands. I want to see if I can pull out my calculator. I don't know if it's going to come up. Here it goes. Now, I want you to use the formula a couple of times, and then you can gladly use the calculator, because this is really, really nice on a calculator, but I just want you to use the formula for a little while so that you get used to it. And then we'll use the calculator steps. These are really nice on your calculator because it's right under your stats button, it's in the test section, and it says interval right on it. So it's the most obvious one. Inverse norm we use a lot, but this one you'll use a little bit more. Alright, so maybe I can't use mine. It's not letting me do this at all. Yeah, but I did. I saved my. Oh, it's on this one. Okay. All right. Thank you. This is such a difficult calculator. Okay, guys, watch up here. If you have a calculator, hit the word stats, the stat button. Now, go over to the word test. And come down, see where the word interval is? We are using a z-score. Aren't we using your z table, your ZC? We are using a z interval. This section is samples larger than 30, greater than or equal to 30. So you come down here. This one's a nice one because it's kind of obvious that it's there. You come down to this one, and it's going to say, do you have data or do you have statistics for me? If you had data, it's probably sitting in your L1 table. But we go to statistics and we say, enter your standard deviation. Your standard deviation from that example was what? 5? 5.0. Okay, your standard deviation was 5. Your sample mean was what? 12.4. Okay, there's your N, 54. There's your confidence interval. You don't have to find your ZC. It does for you. You come down here to calculate. Now you can change that 95. If you want a 90, you put 0.90. If you want an 80, 0.80. And you hit enter. Now, there's your interval. Just watch for 1 second. Okay, we found 13.7 because we only rounded it to here, and we found 11.1, right? Because that's where we rounded it to. Your calculator does a little bit further rounding. Now, it does not give you back your margin of error. However, your mean falls right in between here, right? So 11.066, 12.4, 13.734 are on my number line, like this, with the mean smack in the middle. Guys, watch. This right here is your margin of error. So if you take your high end, 13.7, and you subtract your mean, you get your margin of error without having to use your formula. See it? It's nice. The nicest part about this is probably the ZC. You don't have to find it. You just have to, it just uses it. It internally uses it. So you don't have to even look it up or plug it in. You say 95%, 90%, whatever you need to do. But it doesn't return your margin of error. But all you need to do is take your high end, because this falls exactly in the middle. You could take this and subtract your low end if you want. Just take this and subtract it off of your high end, and that's your margin of error. That's how nice your calculator works. So we recognize it because it says interval, and it says ZC. Okay, so you guys are going to try one now. You're going to try this one. And I'll give you this information.
Miss, I don't know if I got zero on the calculator and I think those two, and I'm not.
But I want you to use the formula. Well, your ZC stays the same because it's 95%. What'd you use for your what'd you put in your formula? What'd you put in your formula?
I didn't fill it out. I just did it all on the calculator.
Okay, okay, what's your calculator say?
That.
No, what's your answer?
Well, you want my answer?
Yeah.
I got 6147.
6147?
Yes. Well, I don't know.
And to when?
It's all on the calculator.
Did you use interval, Leonard? Did you use an interval? Z interval? Try Z interval. Okay, so let's take a look at this. Now, this is your margin of error. You should get 5.9. 5.9. Now, 5.9, we say take your mean, plus or minus 5.9. There's your interval. So you take 14.8 minus 5.9. 8.3?
8.9.
8.9. To where?
20.7.
Now, look at the difference between this interval and the one we just did. I want to be 95% confident that my mean falls between here. I want to be 95% confident. Look how wide that interval is. But if you remember, we had a very large outlier in our 30 pieces of data. There was a 99 sentence thing out there. That's what made this interval be so much larger. Our other interval wasn't very large based on the data that we accrued there. Now, when you do this, that's at the time where you step back and say, is my data correct or not? So I have to look, do I want this sample? Do I need to do resampling? If I get this big of a difference in my samples, yeah, I might want to kick that sample out. Or I might want to say, that happens every once in a while, I need to put that in there. That's why we keep doing multiple samples for these guys. Gunnar, did you do stat Z interval?
Yeah.
And then go to the stat side.
Okay.
So now, when you do this on your calculator and you get this, you have no margin of error. You take your mean and subtract it off the high end. And there's your 5.9. There's your margin of error. So your calculator's a really nice setup for this guy. It does. It's a nice help, but I just want you to be able to see that. Again, we're doing this. We did that one. I did them all together because it's just easier. All right. I want to do one more together here. I want to talk about what happens when your margin of error changes. When your probability is going to increase, your confidence interval is going to increase. In example 1, we did your sentences. In example 1, we had a mean of 12.4 and a standard deviation of 1.3. We had 54 advertisements.
Standard deviation was
5. Thank you. Where did I get 1.3?
That was
Oh, that was the margin of error. Thank you. Okay. Now, I want us to look at the difference between what happens with a 75 and what happens with an 85. This guy is 75. This guy is 85. And I'll tell you what, you can use your calculators for this because we just want to look at your margin of error. So see if you can put this in your calculator and give me,
do it 2 separate times.
you have to do it twice. give me your confidence interval for using this data from your example 1. Let's see what happens when we change the confidence interval. So you're going to go to your calculator. Oh, sorry.
No, not you. Sorry.
I thought you didn't want me to do it.
No, I'm sorry.
So you're going to go to test. You're going to come down to number 7. And you're going to put your data in, which was in from before, unless you changed it. You're going to change this to a 0.85. And you're going to calculate. And you're going to give me your intervals. We're going to set your intervals up on a number line. And then we're going to take a look at your margin of errors as well. Is everybody able to find it on the calculator? It's so much nicer. And it's so much easier when we're looking at this. So, Courtney, give me an interval for 75%.
11.617.
So we'll round it to 11.6.
11.7.
And what's the high end?
13.2.
13.2. Thank you. Anybody get to 85?
I did.
Okay, Gunnar, give me yours.
I'm not even sure what I'm playing.
11.4.
I'm not really sure.
Did you get these? Let Joe take a look at what you put in. Okay. Now, what do you see?
I'm gonna help.
What do we see here? If I make a number line, guys, watch. Here's 11.4. Here's 13.4. This is one interval. My mean is smack in the middle. Here's my second interval. 11.6. Okay, look up here a second. Here is my 11.4, 13.4. This is my 85%. This is my 75%. What do you notice about your 85% interval? It's what?
Got it.
It's bigger, but we're going to say it's wider. It's wider. It's bigger. We have endless numbers, so it's hard to say we have more, we have less. But we're going to say it's wider. It's a wider interval. Guys, this is why. Give me one more minute. This is why. Because when we do this, we want to be more confident than 75%, right? We want to be 85% confident now. So if I want to be more confident, I need a little bit more wiggle room in here. So my margin of error has to be a little bit wider. So as your level of confidence increases, then your interval widens. I want you to use the word widens. Okay, tomorrow we're going to work on some problems.